All right, we're down to our last lecture in our Scala crash course here. This one's going to be about data structures, and it's a very important lecture. We use these a lot, so don't skip this one if you don't know them already. As before, go to the resources for this lecture and please download the Learning Scala 4.sc file. I'll wait for you. Hit pause while you go take care of that. And when you have that, go on out as before to right-click on the Learning Scala project and say Import File System, browse to wherever you download your stuff, and select the Learning Scala 4.sc file. Open it up, and you should see a little something like this. So let's talk about what's going on in here. Okay, so a really common data structure you see in Scala is called a tuple. And you see this in Python and some other languages as well. Basically, it's a collection of stuff that is treated as its own object. So we can make basically this immutable list is how you can think about a tuple. It's a list of objects that you cannot change once they've been created. Very common in Scala. So how do we declare one? You just put them in parentheses and separate the contents of the list by commas. So for example, we can create a tuple called Captain Stuff that contains the strings Picard, Enterprise D, and NCC 1701D. So maybe this is a tuple that represents information about a Star Trek captain and contains individual fields that have different information about that captain. So it's sort of an easy way to pass around, semi-structured data as its own entity. And if we print that out, we can see that gets converted to the string that is, the same syntax within parentheses, the different contents of that tuple separated by commas. So Captain Stuff itself is a single object, but it contains three different values, these three different strings here. So that is a good way to sort of stuff different bits of information into one thing, which comes into handy a lot with Spark, as you'll see later on. Now, how do I get stuff out of it? So let's say I want to extract values out of that tuple. Well, the syntax here, again, with Scala is a little bit weird. What you do is you put a dot after the tuple name and then underscore and the number of the field you want to extract. And the thing you have to remember is that it is a one-based index. So the first value is number 1, the second value is number 2, the third value is number 3. A lot of other things in computer science, you start counting at 0. This is not one of those times. We're starting with 1 here. So for example, if I print captainstuff._1, that extracts the first field of my tuple, which contains the string Picard. ._2 gets the second one, which is Enterprise D. ._3 gets the third element of that tuple, which is NCC 1701D. Okay? With me so far? Nothing too challenging here, but again, you just have to get used to the syntax. Now, a special case is a key value pair, basically a tuple that contains two things. And often you'll use this as sort of a key value mapping. So let's say I want to create a tuple that represents a captain and the ship they command. I could use this syntax to do that. That will just create a tuple that maps Picard as the key to the value Enterprise D. And all that does is give me back a tuple that contains Picard Enterprise D. I could have declared it the same way as I did up here, just by having it within parentheses separated by a comma, but this is sometimes a more readable format that sort of implies to the reader of your code that you are in fact associating a value with a key here, and that's your intent of creating that tuple. You would dereference it the same way you would any other tuple. Picard ship._2 would extract the value from that key value pair because it's the second element and give you back Enterprise D. Whereas ._1, let's try it, would give me back the key, which is Picard. Scroll back up to where we were. There we are. Another thing about tuples, they don't have to all be the same type. You can actually mix and match different types of data within a tuple. So here's an example where we have a string, an integer, and a Boolean all jammed into one tuple, and that's a perfectly okay thing to do. Comes in handy sometimes. So that's tuples. Moving on, take a little break if you need to. Let that sink in, review it. We're good? All right. Lists. Lists are a lot like tuples, but it's an actual collection object, so it has more stuff you can do to it. A little bit more heavyweight, but a little bit more flexible. So kind of like a tuple, you can declare a list. That's just a list of comma-separated values here. And under the hood, it's going to build a singly linked list to represent that information. So here we have a ship list value. That is a list of Enterprise, Defiant, Voyager, Deep Space Nine. So 4 different ships from 4 different Star Trek series in this example. And the syntax of dealing with lists is different than a tuple. So for example, if I want to extract a value from that list, I can just use parenthesis and then the field number I want to extract. So now in this case, we're not starting with 1, we're starting with 0. Okay, so you got to remember that. Very easy to make bugs around this stuff. In this case, ship list 1 will go extract the 0-based element of the list at 1. So we go 0 is enterprise, 1 is defiant. Ship list 1 gives me back defiant. Okay? I know, it's confusing, but it's something you just have to remember with Scala. Now, .head will give you the first element of the list. .tail will give you all the remaining elements of the list after the head. Okay, so in other languages, tail might return the last element. That's not how it works here. Tail gives you actually a list, a sublist of the list that just excludes the first element. And sometimes that's useful if you're iterating through a list and you need to extract one item and then, keep working with the remainder of that list in the next iteration. Okay. Now, let's say I want to iterate through an entire list and do something to every value within it. That's something you need to do pretty often. So remember that that range operator we introduced back when we talked about flow control? Well, same trick applies to lists. So we could say for ship in ship lists, and that will actually produce a range, an iterator that goes through every ship in the ship list and assigns it to the ship variable. And we can print out each ship one at a time that way. So this code here, again, the key is this little range operator here that will go through the ship list, extract each individual element into a new value called ship that we can then print out within this expression. So that will go through and print out each individual ship in our ship list. More fun with lists here. We can also use the map function to actually transform a list using some expression. So let's take a look at what's going on there. Let's say I have my ship list of ship names, Enterprise, Defiant, Voyager, Deep Space Nine. I can call .map to actually apply an expression, some function, to every element of that list one at a time. So in this case, I'm actually defining a little function inline that takes a string called ship and maps it to ship.reverse, which just reverses the characters in each string. So what that does is say I want to take this function that reverses a string and map that to the ship list and return a new list called backward ships that contains the backwards names of all the ships. Okay, so stare at that line for a little bit until it sinks in, and the output is exactly what we want. So we have a list of all the ships with their names backwards. Okay, so that's what the map function does. It just applies some function that transforms each element of the list into a new list. Okay, and we can go through and print out those results too, just using that same trick with the range operator there to print out the results. And sure enough, we get the backwards versions of each ship name printed out one at a time. Okay, with me so far? Okay, so that's mapping. That's the map function. Mapping, sound familiar? MapReduce, same concept, same exact concept. The only difference is that we're not actually doing this in a distributed manner. We're just using Scala's built-in operators on the list to actually map one list to another. Now, I said MapReduce. Can't talk about map without reduce. And sure enough, there's a reduce method on list as well. So just like we can use map to apply a transformation to every individual element of a list, we can use the reduce function to actually combine the contents of a list together. So here we're going to start with a number list. That's just a list of the numbers 1, 2, 3, 4, and 5. I can call reduce on that list with a function that tells how to combine these things together. So basically what reduce does is it goes through each list, and as it gets each pair of items, it will use the function we provide to combine them together. So basically we're saying as new values come in from the list, add them up. So as I get two values that are processed together, I'm going to add them up, take that result, add in the next value, take that result, add in the next value, and so on and so forth until we're done. So basically this is a way of saying I want to take the entire list, sum up all of its values, and give me back the result. And what that does is iterate through the list, one pair of values at a time. So it takes 1 plus 2, says that's 3. 3 plus 3 is 6. 3 plus 4, 6 plus 4 is 10. 10 plus 5 is 15. Using that reduce operator, that reduce function we provided, and sure enough, the answer we get back is 15. And we can print out that result. Sure enough, 15. And hey, that's MapReduce. You know, the only difference is that in a real MapReduce application, you would be using functions that actually work on a cluster. Same concept though. Filter also can be used, and if you've looked at Spark or MapReduce before, that might also look familiar. you can actually use that to create a sublist based on some filter function you define. So in this example, we're going to say, I have a new list called I hate fives, and I'm going to take my number list that contains the numbers 1, 2, 3, 4, 5 and apply a filter that tests to make sure that x does not equal 5. So I have in here a little inline function, a function literal if you will, that takes an integer x and tests if x is not equal to 5. And that Boolean result of that function will determine whether or not that individual list element survives and gets passed into the resulting list. So what goes on here, we start with 1, 2, 3, 4, 5. We apply this filter function to it, which will allow everything but the 5 to pass through. And you can see that we end up with a list 1, 2, 3, 4 where 5 has been excluded. You can do the same thing again here. A little bit of a more compact syntax here that you often see. Same idea, but here we're using a little bit of a syntactical shortcut. You can actually say in a function literal underscore to just say whatever it is not equal to 3. So that is sort of implicitly removing this x transformed to x and just simplifying it down to, hey, I know I only have one parameter coming in. I want to take that parameter, whatever it is, and just compare it to 3. Okay, and you can see that works just as well. If I apply this filter function that makes sure that each element represented by that underscore is not equal to 3 is all that passes through, then I end up with 1, 2, 4, 5, where the 3 has been omitted. So, you do see this a lot in Scala, where we have these, people that want to save keystrokes at the expense of readability, but you need to understand that when you see it. Okay. Now, Spark, has its own map, reduce, and filter operations that can actually happen in a distributed manner. The only difference is that we'll be not operating on list structures, but something we call RDDs, but we'll get to that later. But same exact concept. So if you understand how this map and reduce function and this filter function worked, hey, you understand MapReduce now, and you also understand a good part about how Spark works. It's all the same idea. It's actually not that complicated. A few more list tricks here. Let's say I want to concatenate two lists together. We have our 1, 2, 3, 4, 5 list, number list, and I want to concatenate a new list called more numbers that contains 6, 7, 8. The plus plus operator will combine two lists together, and that gives us back the combined list 1, 2, 3, 4, 5, 6, 7, 8. Okay. A few more tricks. Every list has a dot reverse method that will give you the reversed list, so 5, 4, 3, 2, 1. It has a dot sorted method that will return a sorted version of that list. So here I took my reversed list that was 5, 4, 3, 2, 1, called dot sorted on it, and that returns a new sorted list that's back to 1, 2, 3, 4, 5. Let's look at distinct. So let's say I take my number list and append itself, number list plus plus number list, and I get 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. If I just want the distinct values in that list, I can call dot distinct and just get back 1, 2, 3, 4, 5 because those are the numbers that only appear once. Okay. So we also have a dot max function that will find the maximum value in a list. Sum will sum them all up if they are numbers that can be summed. And I also have a dot contains function that can be used as a quick test to see if a list contains a given value. So I hate threes, where we filtered out the number 3, contains 3, will return false because it has everything but 3. All right, that's lists. I want to take a break here, let it sink in, because we're going to move on to maps now. All right, maps. Maps, just like maps in other languages, sometimes they're called dictionaries. Basically, they're a lookup table of given keys to values. So the way to declare a map in Scala is something like this. So let's say I want to create a map that maps starship captains to the ship they commanded. So here we have a map of Kirk maps to Enterprise. So we have this dash greater than sign syntax mapping keys to values here. Picard associated with Enterprise D, Cisco Deep Space Nine, Janeway to Voyager. And we can actually do a lookup very simply here by using this parenthesis key name here to extract the value associated with that key. So ship map Janeway returns Voyager. Okay, very easy to use. Now, one complexity is that when you're dealing with maps, you need to deal with missing keys, right? So what if I did like Archer, okay? That wasn't in my list of original captains, in my list of keys for this map. So what happens if I try to extract Archer? Well, that should generate an exception. So one way to protect against that is to make sure that the map actually contains the key you're looking for first. So if I do that test, I can say shipmap.contains Archer. That will return false because shipmap does not have a key for Archer. And at that point I could say, well, I know that key doesn't exist, so I'm not going to try to extract the value for that key because I know that would lead to an error. Another way you can deal with it is by using this try syntax. So, Just like try exception blocks or try catch blocks in Java, similar concept there. What we're going to do is use this util.try function that's built into Scala to actually extract the value for Archer from shipmap. And what's going to happen is that's going to generate an exception because there is no key for Archer in shipmap. But instead of erroring out, we're going to wrap it in this util.try so it catches that exception. Get or else says, I want to actually get the value of this expression here, but if it generates an exception, here's my fallback value of unknown. And if I go ahead and execute that, you can see that when I try to do shipmap Archer, that does generate an exception. Get or else handles that exception and returns the string unknown in that case. So that's a safe way of accessing a map where you're not sure if the key is actually in it or not. All right, those are all the main data structures that we need to deal with Scala. There are others, when we'll maybe touch on one or two more of them as we go through the course. Obviously, there's a lot more to Scala than we've talked about here. We haven't even really gotten into object-oriented Scala and some of the more, mundane details of the language that might come up from time to time. But as new concepts come up through this course that you might need, I'll introduce them to you as we go. This is all you need to get started. So these are the basics of Scala. If you do want to learn more, there's a good book called Learning Scala by O'Reilly that I recommend. I don't get any money if you buy it or whatnot, but really good reference, and it does go into all those little details that I talked about if you want to learn more. But that's enough to get you started. I think that's enough for now. So let's just start to dive into some actual Spark streaming next, shall we? And congratulations, you now know Scala. Woohoo!